Hi everyone, I am Ümit Alkuş. In this video, we will solve one problem from chapter 30. The figure shows a circuit containing a capacitor and an inductor. Find the main current I, A, at t equals 0 and B at t equals infinity. For an RC circuit, the voltage difference between the plates of the capacitor is calculated by the formula Vc equals epsilon times 1 minus e to negative t over Rc, where R times C is the capacitive time constant. At time t equals 0, Vc is epsilon times 1 minus e to 0. Since e to 0 is 1, then we obtain 0 voltage. This is to say that capacitor behaves like a short circuit. At time t equals infinity, Vc is equal to epsilon times 1 minus e to negative infinity. E to negative infinity is 1 over e to infinity, which is then 0. So, the voltage difference Vc is equal to epsilon, from which we claim that the capacitor behaves like an open circuit. For an RL circuit, the current passing through the inductor is calculated by the formula epsilon over R times 1 minus e to negative t over L over R, where L over R is the inductive time constant. At time t equals 0, the current IL is epsilon over R times 1 minus e to 0. E to 0 is 1, therefore the current is 0. Therefore we say that at time t equals 0, the inductor behaves like an open circuit. At t equals infinity, the inductor current is epsilon over R times 1 minus e to negative infinity. E to negative infinity is 0. Then we obtain epsilon over R. This is equal to say that the inductor behaves as a short circuit. In part A, when the switch S is on, the capacitor behaves like a short circuit and the inductor behaves as an open circuit. The equivalent resistance for the parallel resistors is 1 ohm. Now 1 ohm resistor is in series with the resistor 2 ohm. Then the equivalent resistance is 3 ohms. And the main current I is calculated by the formula V over R equivalent. V is 12 volts and R equivalent is 3 ohms. Then the current is 4 amperes. After the switch is on, at time t equals infinity, the capacitor behaves like an open circuit, and the inductor behaves as a short circuit. And this 2 ohm resistor is useless. So is this resistor. Then the equivalent circuit becomes the main current I is equal to then 12 volts over 2 ohms, which is 6 amperes. This result brings us to the end of the discussion of this problem. Thank you for your attention. See you on the next video.